In this video lesson, we are going to study preparation of aldehydes and ketones. We will be emphasizing on the oxidation of primary alcohols to aldehydes and the oxidation of secondary alcohols to ketones. Then we will move to reduction reactions of aldehydes and ketones. Here, we will be studying the reduction of aldehydes to primary alcohols and the reduction of ketones to secondary alcohols. Before continuing with our topic today, please like this video and subscribe to our channel. Do not forget to hit the notification bell. As you know from our previous video, you know what is oxidation. I said oxidation is the addition of oxygen to a molecule and a subsequent removal with oxygen with a hydrogen. You add oxygen atom to a molecule and later on you remove it with hydrogen. This is the procedure we are going to use in the preparation of aldehydes, aldehydes as well as ketone. Our reagent here, the suitable reagent in this preparation will be acidified potassium dichromate 6, or you could use acidified potassium manganate 7. But remember that the primary alcohol must be in excess. The primary alcohol in this process must be in excess. And this primary alcohol must be heated under reflux with either acidified potassium dichromate 6 or with acidified potassium manganate 7. Lastly, it should be remembered that the aldehyde that is formed as a result of this oxidation process should be distilled off immediately. The aldehyde formed is distilled off immediately. So this is the process. Our example will be, we'll be taking ethanol as a primary alcohol. We will be taking ethanol in this case as our primary alcohol. You can have, this is ethanol, CH3, sorry. CH, CH3, CH2, OH, addition of oxygen to a molecule. Remember that the oxygen in the square bracket, this is how it is being used when it has to do with oxidation in organic reactions. This oxygen in square bracket symbolizes that the oxygen is from an oxidizing agent. The oxygen given here is from an oxidizing agent. We'll have this. Plus a molecule of water that is always removed. Let me put it better understand here. I said you can use acidified potassium dichromate 6, or you could use manganate, acidified potassium manganate 7, but it is heated under reflux. As soon as the ethanol is formed, it should be distilled off immediately. Here we have ethanol. This ethanol. Here we have ethanol. And this is water. What happens here is, what is happening here, just take a look at it. This is the oxygen that has been donated by the oxidizing agent. You should know that that is what is happening. The oxygen that is given by the oxidizing agent, addition of oxygen into a molecule, and remover with hydrogen. So now it is a molecule of water that is being eliminated. I said once more in this reaction, I said the primary alcohol used must be in excess. And this alcohol, for instance, the ethanol, is heated under reflux with acidified potassium dichromate 6 or acidified acidified potassium manganate 7. And as soon as the ethanol form, it should be distilled immediately. As soon as the ethanol is formed, it should be distilled off immediately. So that is our reaction. So this is ethanol, which is the aldehyde produced by the oxidation of a primary alcohol, which is the ethanol. Note under this condition, if the product formed is not distilled off immediately, it will further be converted to corresponding ethanoic acid. That is it. I'm saying that, note, if the product formed, that is the ethanol, is not distilled off immediately, it will be further converted to the corresponding carboxylic acid, which is ethanoic acid, and this is how it can be done. The ethanol, this is the ethanol. This is the ethanol. This is the oxygen. It will undergo further. It's going to undergo further oxidation if it is not removed. And this is the product that is being produced. I said O. ethanol will now come to what we call ethanoic acid. So now, as I said, if the product form is not distilled off immediately, if ethanol is not removed immediately from the, removed immediately, there is going to be a further oxidation that will end up in ethanoic acid. Okay, we are done with the preparation of aldehyde from primary alcohol. Now we can now move to the preparation of ketone from secondary alcohol. Under the same condition, acidified potassium dichromate or acidified potassium manganate 7, heating under reflux, the product form will be a ketone. The product form in this case will be a ketone. So what you need here is a secondary alcohol to produce a ketone. A secondary alcohol. So, excuse me, heating a secondary alcohol with acidified potassium dichromate 6 or acidified potassium manganate 7 solution under reflux will oxidize the secondary alcohol. It will oxidize the secondary alcohol to a ketone. Our example that we are going to be using here, we want to use propan 2-ol as an example of secondary alcohol. Propan 2-ol as an example of a secondary alcohol. Oxidation is taking place to give I will have CH3, CO, CH3, and a molecule of water that is always eliminated. And the molecule of water that is always eliminated. Now I can go further to show how the bonding, how the oxidation is taking place. From this structure, you can see that is propan 2-ol. That is CH3. CH3 is we will have a ketone here. Will be a CH3 plus a molecule of water that is being eliminated. Plus a molecule of water that is being eliminated. But in that case, what is happening? We have acidified potassium dichromate, or you could use acidified manganate seven. Now, what is happening here is, see how the oxygen from the oxidizing agent comes. That is where the oxygen comes. Now a molecule of water now goes along with. So that is how you see the whole thing going. That is, in that case, we have here as our, this is propanone, I mean propan 2-ol, propan 2-ol. Now, propan 2-ol now gives us propanone. Then a molecule of water that is also produced. This water here. That is water. So you can see how the oxidation process is taking place to produce our final product. As I earlier said, our reagent, we have acidified potassium dichromate 6 or acidified potassium manganate 7. All these solutions are heated under reflux. I mean, any of them, you can use any of them. You can either use the acidified potassium dichromate or acidified potassium manganate 7. Any of them could be is suitable for this oxidizing process. Then we now put in our secondary alcohol, which are our example in this situation is propan 2-ol. Then we heat it under reflux. And the product that results from this procedure is propanone. It's propanone that is being produced and a molecule of water that is being released. Now, note, there is one thing you should note, that, note that, note, note that ketones will not be further oxidized under this condition, except phenylethanone. Ketones, note, will not be further oxidized. Will not be further oxidized under this condition. Under this condition, ketones will not be further oxidized, except the only one that we can that can be further oxidized is phenyl phenylethanone. Phenylethanone is the only one that can further be oxidized. Let me just show you how it can go. We have we can have a product like this if we use a phenyl ethanol. We will have a product like this. We will have a product like that, plus water, and plus carbon dioxide. So now this is what you can get. Ketones will not be further oxidized under this condition, except phenylethanone that can be further oxidized to this product. Okay, so now this moves us to our second section. We are done with oxidation. We are done with oxidation of aldehydes and ketones. Oxidation of aldehydes and ketone. That is the same. That is preparation of aldehyde and ketone through oxidation. Now we have to go but to reduction. Now we are done with preparation of aldehydes and ketones, preparing aldehydes from primary alcohols using suitable oxidizing agent, preparation of ketones from secondary alcohol using suitable oxidizing agent, and finally I said ketones are not further oxidized, except the only one that can undergo that is a phenylethanone. We are done with oxidation once more. We now go to reduction of aldehydes and ketones. Reduction of aldehydes and ketones. You know very well, reduction is the reverse. This is the reverse of oxidation reaction. In oxidation, we were preparing we were preparing aldehydes from primary alcohols. In oxidation, we were preparing ketones from secondary alcohol. On the other hand, reduction. How can we reduce aldehyde back to primary alcohols? How can we reduce ketone back to secondary alcohol? This is the reverse of oxidation, and this is carried out using two reagents. These reagents, this is carried out using two reagents. We have a lithium tetrahydroaluminate, that is LiAlH4, in dry ether. We also have sodium tetrahydroborate in aqueous alcoholic solution. Now, the procedure in this, the procedure here is that you will have to warm the aldehyde or the ketone with any of these reagents. So now let me just come first. Remember that lithium that's LiAlH4, lithium tetrahydroaluminate, and NaBH4, that is sodium tetrahydroborate, are acting as reducing agent. This is reduction. All these are acting as a reducing agent. This and that are acting as reducing agent. They are acting as reducing agent, as well as what? As well as providing the nucleophile. They act as the reducing agent. Two, they also provide the nucleophile. They also provide the nucleophile. This nucleophile, this is the nucleophile. This is the nucleophile. Now, that is a nucleophile. Let me draw it very well for you to better understand the structure of this. Is lithium plus. We have there is aluminum here. Lithium. So we have in dry ether. In dry ether. We will also have this other molecule here. We will have boron here. Yeah, this structure NaBH4, NaBH4 in aqueous alcoholic solution. Aqueous alcoholic solution. Then I said what I mentioned is what I said is that the ether, the dry ether, an example of the dry ether, is you can use diethyl ether. Diethyl ether. Diethyl ether is an example of dry ether. Diethyl ether at room temperature. You can at room temperature. So now remember that NaBH4 in aqueous alcoholic solution, in aqueous this thing is a weaker is weaker than the lithium tetrahydroaluminate. LiAlH4, lithium tetrahydroaluminate in dry ether is more powerful. This is more powerful reducing agent than the NaBH4, and it reacts vigorously. The lithium tetrahydroaluminate, which is LiAlH4, is a more powerful reducing agent than the NaBH4, and this powerful reducing agent reacts vigorously. So now, in this preparation, you can either warm the aldehyde, or the ketone with any of these reducing agent. We want to start in the first case with, we'll be starting with, let me say, reducing the aldehyde to primary alcohol. Our example is what? The aldehyde that was produced the other time was ethanol. We want to see use ethanol, the reduction of ethanol to ethanol. Example, we'll be using aldehyde, from aldehyde to aldehyde reduced to ethanol, to alcohol. Let me just say alcohol. Our example will be, we are going to use ethanol, ethanol to ethanol. Now, let's start here. Let's say you will see it here that for example, ethanol is CH3 C plus what was under this condition is again, hydrogen in a square bracket indicates that it is from a reducing agent. It is from a reducing agent. The product will be that is the product. So now the product will be ethanol, which is this is CH3 CH2 ethanol. Ethanol. That is method two. Method two, you can still produce primary alcohols by what? By catalytic hydrogenation of aldehyde. Catalytic hydrogenation of aldehyde. Method two, let me say method two, catalytic hydrogenation. Catalytic hydrogenation catalytic hydrogenation of aldehyde to form what? To form primary alcohol. To form primary alcohol. And this is how you can get that one. We will have the equation R2 CO a nickel catalyst is used Okay, that's how you can produce that. Once more, reduction of aldehyde. This is the reverse of oxidation. As I said, is the reverse of oxidation. And in other words, we can call this as nucleophilic addition reaction of aldehyde. We are adding a nucleophile. The nucleophile is the H minus. This is the nucleophile, the H minus. This reduction reaction can equally be called nucleophilic addition reaction of aldehyde. We add the nucleophile to the aldehyde. And I said suitable reducing agents are, the first one is lithium tetrahydroaluminate, which is LiAlH4. And the second one is sodium tetrahydroborate in aqueous alcoholic solution. I said these two reducing agents are acting as they are acting to provide the nucleophile. These are reducing agents. They are acting to provide the nucleophile. And I went further. I said LiAlH4, which is lithium tetrahydroaluminate in dry ether, is a more powerful reducing agent than the NaBH4. And this LiAlH4, which is lithium tetrahydroaluminate, reacts vigorously. Then, to show how aldehydes can be reduced back to primary alcohol, I said you will warm this reducing agent. You have to warm this reducing agent with the primary alcohol. This reducing agent with the primary alcohol, when heated, does what? It is converted back to the primary alcohol. And our example here is ethanol. I'm using ethanol. How can we reduce ethanol back to ethanol? We heat the ethanol with the reducing agent. The reducing agent helps to provide what? To provide the nucleophile. That is the H minus. It provides the nucleophile. The two hydrogens there which are being provided are provided by the reducing agent. So now we add them to this ethanol, and the final product will be ethanol. When we go into the mechanism, you will see how there is this is a nucleophilic addition to the ethanol. When we get to the mechanism. Now, I said primary alcohol, alternatively, primary alcohol can still be produced or can still be prepared by catalytic hydrogenation of aldehyde. And the catalyst is usually a nickel catalyst. This is just an example. Then we want to see how the ketones can be reduced back to secondary alcohol using the same suitable reducing agent. Now, ketones. The ketone, and our example of the ketone here will be we said ketones can be reduced. Ketones can be reduced back to what? They can be reduced back to secondary alcohol. they can be reduced back to secondary alcohol. Reduction. And I will give you an example of the ketone we are going to use here. Our example of the ketone we are going to use here will be propanone. Propanone to propan-2-ol. Propanone to propan-2-ol. Then I want to let me show it how this is done. We will have, let me say this as CH3. Yeah. We will have a CH3 This is propanone. This is propan-2-ol. This is propan-2-ol. So now you have this propan-2-ol. So you see that propan-2-ol, yeah, which equally could be, you want to write the structural formula, it's okay. So that is just how you can produce it. So a recap of our study today. A recap of our study today. We have treated oxidation and reduction of aldehydes. Preparation, we said preparation of aldehydes and ketone using oxidation. Aldehydes can be prepared from primary alcohol using suitable reagent such as acidified potassium dichromate solution, acidified potassium dichromate 6 solution, or acidified potassium manganate 7 solution. I said this is heated under reflux. With aldehyde, the product formed should be distilled off immediately, because if allowed for some time, it will further be converted to the corresponding carboxylic acid. And the ethanol in this situation, I said if allowed to stay for some time, it will undergo further oxidation into ethanoic acid. We went further for the preparation of ketone from secondary alcohol. We use the same reagent. Any of the reagent could be used. And heated under reflux. Using our example of propan-2-ol, we had propanone and a molecule of water that was eliminated. Now, we went to reduction of aldehydes and the ketone. This is a reversible, this is the reverse of the oxidation process. Oxidation was preparing aldehydes from primary alcohol and ketones from secondary alcohol. Now this is the reverse. How can we get back to primary alcohol or secondary alcohol? This is through reduction. In other words, we call it nucleophilic addition reaction of aldehyde and ketone, because the nucleophile there is provided by the reagents. And the two reagents here, we said there are lithium tetrahydroaluminate, which is LiAlH4 in dry ether, or sodium tetrahydroborate, in aqueous alcoholic solution. These are two reagents. You could use one or the other. I said LiAlH4 is a more stronger reducing agent, and it reacts vigorously than NaBH4. So I said, in preparing this, aldehyde will be reduced to alcohol using this reagent. And our first example was to use ethanol that we got in the first occasion. The ethanol, by adding hydrogen there, we went back to ethanol. Now, I said alternatively, another method you can still prepare primary alcohol is by using a catalytic hydrogenation of aldehyde. Now, the catalyst was nickel catalyst, and I've just given an example. Then we went further how ketones could be reduced to secondary alcohol. And our example for ketone is propanone. Propanone can be reduced to propan-2-ol, and using the same reagent, using the same reducing reagent, which is lithium, which is either lithium tetrahydroaluminate or sodium tetrahydroborate. Any of them could be used to reduce propanone back to propan-2-ol. When we do that, when we did that, we had this product, propanone to propan-2-ol. Learners, if you haven't subscribed to our channel, please subscribe, and do not forget to hit the notification bell. Thank you for watching.